You can have the most expensive analytical testing equipment in the world, but if your sample preparation is wrong, your final data is completely useless. Think your material testing results are flawless? What if the biggest error happens before the test even begins? Today we are diving deep into why sample preparation is the undeniable first step to accurate material testing. Welcome back to the channel. When we talk about laboratory equipment and material testing, everyone wants to focus on the final analytical results. The breaking strength, the chemical composition, the precise moisture content. But experienced lab technicians and engineers know a dirty little secret. The quality of your output is entirely dependent on the quality of your input. Sample preparation is the meticulous process of taking a raw, uneven, bulky field sample and transforming it into a homogeneous, representative specimen that your analytical instruments can actually read. If your sample isn't perfectly blended, crushed, or milled down to the exact micron size required by ASTM or AASHTO standards, you are going to get skewed results. You might pass a batch of asphalt that should have failed, or reject a concrete mix that was actually perfectly sound. To prevent these catastrophic errors, you need the right laboratory equipment. You need machines that can handle high throughput without cross-contamination. You need grinders, crushers, and mills that offer repeatable, reliable performance every single time you flip the switch. In this comprehensive guide, we are going to break down 4 essential pieces of sample preparation equipment that every serious material testing lab needs. We will explain exactly what they do, and more importantly, give you a simple explanation of how to use each of these 4 products to achieve perfect material homogeneity. Let's start with a powerhouse for soft, medium-hard, brittle, and fibrous materials, the WRETSCH M300 Ultracentrifugal Mill. When you need high-speed, highly efficient size reduction, this is your go-to laboratory instrument. How it works, think of the WRETSCH M300 like an industrial-grade, incredibly precise super blender. But instead of just chopping things up blindly, it uses centrifugal force. You drop your material in the top, and a high-speed spinning rotor flings the material outward against a sharp metal screen called a ring sieve. The material is instantly sheared and crushed between the spinning rotor teeth and the screen until it is small enough to pass through the tiny holes. How to use the WRETSCH M300 is step-by-step. Using this machine is designed to be user-friendly while maintaining strict lab safety. Step 1. Select and install your desired push-fit rotor and the appropriate ring sieve based on your target particle size. They slide easily into place without tools. Step 2. Lock the grinding chamber securely and turn on the machine using the digital touchscreen interface. Set your desired speed. The ZM300 can reach incredibly high speeds for rapid grinding. Step 3. Slowly and steadily pour your raw sample into the feed hopper at the top. The load sensor will automatically monitor the feed rate to prevent the machine from jamming or overheating. Step 4. Once the grinding sound stops, power down the unit, open the chamber, and collect your perfectly pulverized, homogeneous sample from the patented cassette system. The cassette makes it incredibly easy to recover 100% of your sample with zero cross-contamination before your next test. Now, what if your material is way too big and way too tough for a centrifugal mill? What if you are dealing with chunks of raw granite, hardened concrete cores, or heavy ores? That is where the mini jaw crusher with a 2 by 2 inch feed opening comes into play. This is the heavy artillery of primary size reduction. How it works. Imagine a giant mechanical nutcracker made of heavy-duty steel. It has 2 plates inside. One stays completely still, while the other moves back and forth on a pivot. When you drop a large rock between them, the moving plate crushes the rock against the stationary plate until the pieces are small enough to fall through the gap at the bottom. It takes big rocks and violently chews them down into manageable gravel. How to use the mini jaw crusher? Step-by-step operating the mini jaw crusher requires attention to safety, so always wear your safety glasses and hearing protection. Step 1. Before turning the machine on, adjust the gap setting at the bottom of the jaw plates. This gap dictates your final crushed particle size. You can easily adjust this using the manual tension knobs on the exterior of the machine. Step 2. Turn on the heavy-duty motor. You will hear the powerful rhythmic chugging of the toggle mechanism. Step 3. Take your coarse sample, ensuring no single piece is larger than the 2 inch by 2 inch top feed opening, and drop it into the hopper. Never force material down with your hands. Let gravity and the jaws do the work. Step 4. Place a collection pan beneath the discharge chute. As the jaws crush the material, the properly sized aggregate will fall seamlessly into your pan, ready for the next stage of secondary, fine grinding, or direct sieve analysis. So you've crushed your large rocks, but what if you need to take a small sample down to an absolute microscopic powder? Enter the WRETSCH MM400 Mixer Mill. This is an authentic benchtop workhorse designed specifically for high-performance dry, wet, and cryogenic grinding of small sample volumes. How it works, the MM400 is basically the most intense paint shaker you will ever see. You place your sample inside a small steel jar along with a heavy steel grinding ball. The machine then vigorously shakes the jar side to side up to 30 times per second. The heavy ball violently bounces around inside, smashing into the sample over and over again until the material is completely pulverized into an ultrafine dust. How to use the WRETSCH MM400 step by step. This mill is perfect for rapid reproducibility. Here is how you run it. Step 1. Take your empty grinding jar and place your pre-crushed sample inside. Next, place your grinding ball or multiple smaller grinding beads inside the jar on top of the sample. Step 2. Seal the jar tightly with its lid. Step 3. Place the jar into the clamping mechanism on the radial arm of the mill. Tighten the locking wheel securely. The MM400 has 2 stations, so you can lock in 2 jars to balance the machine and double your throughput. Step 4. Use the digital keypad to set your oscillation frequency and your grinding time. Usually, it only takes between 1 to 3 minutes to completely pulverize a sample. Step 5. Hit start. The machine will shake rapidly. Once the timer finishes, unlock the jars, remove the grinding ball with a magnet, and your sample is now a perfectly uniform fine powder ready for X-ray fluorescence or chemical extraction. Finally, let's talk about maintenance and the consumable heart of your heavy-duty pulverizing equipment. If your lab uses a standard BICO bronze pulverizer, the machine is only as good as the grinding plates inside it. We are looking specifically at the BICO bronze pulverizer chrome alloy steel grinding plate set. How it works. Think of these plates like 2 extremely heavy, metallic grinding stones at an old-school flour mill. One plate stays fixed to the door of the machine, while the other plate spins rapidly on a motor shaft. Your crushed rocks are fed between them, and the intense friction and grinding action rub the rocks down into a fine, sand-like powder. Over time, these plates wear smooth and need to be replaced to maintain accurate particle size reduction. How to use and install the grinding plate set. Step-by-step installing and using these plates correctly is vital for machine longevity. Step 1. Unplug and isolate the power to your pulverizer for safety. Open the heavy iron grinding chamber door. Step 2. Unbolt and remove the old stationary plate from the door and the rotating plate from the drive shaft. Step 3. Take your new chrome alloy steel grinding plates. Bolt the new stationary plate securely onto the inside of the door. Slide the new rotating plate onto the main drive shaft and secure it tightly. The chrome alloy steel construction ensures long wear life and resists abrasion from hard silicate rocks. Step 4. Close and latch the pulverizer door. Adjust the manual clearance dial on the outside of the machine to set the gap between the 2 new plates. This gap determines how fine your final powder will be. Step 5. Turn the machine on, pour your mid-size aggregate into the top funnel, and let the fresh, sharp grooves of the new alloy plates effortlessly grind your sample down to your exact required mesh size. In material testing, poor sample preparation ruins your data and wastes your time. Whether you need the precision of the WRETSCH ZM300, the raw power of a mini-jaw crusher, the ultra-fine milling of the MM400, or fresh BICO bronze plates, having the right equipment is non-negotiable. Ready to upgrade your lab and eliminate errors before they happen? Head over to Certified MTP today. Click the link in the description to find the exact machines we covered. Don't forget to like, subscribe, and hit the notification bell for more from Certified MTP. See you in the lab next time.